The objectives of today's lecture will enable you to understand the chemistry of some important transition elements in which we are going to study the chemical reactions of iron 2 and iron 3 ions with carbonates and thiocynates, and after that we are going to cover the topic of copper. We are going to study the chemical reactions of copper ions with hydroxyl ions, ammonia and carbonates. Students, let us start with the reaction of iron 2 and iron 3 ions with carbonate ions. Now students, when iron 2 and iron 3 ions are going to react with carbonate ions and thiocyanate ions, they show different chemical properties, unlike the reactions that we studied in the previous topics, which was with hydroxyl ions and ammonia. Iron 2 and iron 3 ions was showing a similar mechanism. But students, they are going to react differently with iron 2 ions and iron 3 ions when we are going to react it with thiocyanate and carbonate ions. So students, when the reaction of iron 2 ions take place with carbonate ions, what is going to happen? Iron 2 ions react with carbonate ions. Green precipitates of iron carbonate is formed. Now students, Fe plus 2, or we can also say that if it is present in the solution, it is going to be hexa aqua iron 2 complex ion. So when it is going to react with carbonate ions, it is going to form FeCO3, which is iron 2 carbonate, or simply we can say iron carbonate. Now students, look at the electrostatic charges plus 2 and minus 2. So they are going to electrostatically attach to each other, and this is not a complex, although it is neutral. It is going to give green precipitates which are going to settle at the bottom. Now students, notice that although carbonate ions are also bases, but unlike hydroxyl ions and ammonia, they are not going to extract protons from hexa aqua iron 2 complex. Instead, the ferrous ions are going to combine with carbonate ions to form an ionic compound. So over here, carbonate ions, they are not acting as a base and they are not going to take out protons from the water molecules which are attached as ligands. Now students, let us study the reaction of iron 3 ions now with carbonate ions. The hexa aqua iron 3 ions, they are sufficiently acidic and they react with a weak base which is carbonate ions. If we add sodium carbonate solution to a solution of hexa aqua iron 3 ions, this is the carbonate solution. If we are going to add it in the hexa aqua iron 3 solution, carbonate ions remove hydrogen ions from water ligands, just like we studied in the hydroxyl ions. They are going to form hydrogen carbonate or carbon dioxide, and reddish brown precipitates of hydroxide of iron 3 complex is formed. Now look at the chemical reaction in order to understand it. Now students, this is the yellow colored hexa aqua iron 3 ions. This is the solution of it. When we are going to add sodium carbonate solution, the carbonate ions, they are going to act as a weak base. And this weak base is going to take out protons or hydrogen atoms from water. 3 carbonate ions are going to remove 3 hydrogens from 3 water molecules which are present as a ligand in this complex, and is going to give us a complex, a neutral complex, which is triaquo trihydroxyl iron 3 complex, which is reddish brown in color, and these precipitates are going to settle at the bottom. Now students, along with it, we are going to obtain carbon dioxide. You can see in this test tube that the carbon dioxide molecules, they are bubbling out. The bubbles of carbon dioxide are going to evaporate from this test tube. Along with it, we are going to obtain 3 water molecules. Now students, you have noticed the difference in the chemical reaction of iron 2 ions, which was forming FeCO3. But in iron 3 ions, we are getting a reddish brown complex. Now students, let us study the third reaction of iron ions with thiocyanate ions. But students, with thiocyanate ions, we are only going to study the reaction with iron 3 ions, not with iron 2 ions. This is identifying test for the presence of iron 3 ions in this solution. Because thiocyanate ions, they do not react with iron 2 ions in such a manner. If we add thiocyanate ions, SCN of potassium or ammonium. Now students, by this we mean to say that the solution can be comprised of either sodium cyanate, potassium cyanate or ammonium cyanate. Means we are taking a salt of it, and as a solution it is going to split up into the respective ions like SCN negative. Now students, if we are going to add it in the solution containing iron 3 ions, means hexa aqua iron 3 ions, we are going to get an intense blood red solution containing the complex, which is going to be such a complex containing a +2 charge. Now look at the chemical equation. SCN negative ions from any of these salts, when it is present in the solution, is going to react with iron 3 complex. Now students, the product that is obtained is going to be blood red solution of this complex, which is penta-aquo thiocyanato iron 3 ions. Now students, why it is an ion? Because thiocyanate carries -1 charge, water gives 0, the overall charge is +2, so -1 and +3 is going to give +2. Now students, over here you can see that thiocyanate ions, they are not acting as a base and they are not removing protons from these water ligands. Instead, itself it is going to act as a ligand and incorporate into the coordination sphere by the removal of one water molecule or one ligand. Now students, you can see in this complex only 5 water molecules or ligands are present, and one of the water molecule has been replaced by thiocyanate ions. But the coordination number remains the same. It is 6 for iron in this complex and it is 6 for iron in this complex as well. 5 and 1, 6. And the water molecule which was removed, it is removed out of the coordination sphere and leaves as a independent water molecule. Now students, over here we are not obtaining precipitates. It is a blood red solution. Why? Because look at the coordination sphere, it is not neutral. When the coordination sphere is neutral, then we obtain precipitates. But since it is ionic, it is a cationic coordination compound or complex, that is why it is soluble in the water. But this complex is giving blood red coloration. So this blood red coloration is used as an identification test for the presence of iron 3 ions when we are going to react it with thiocyanate ions. And such a coloration or chemical reaction do not take place when we use iron 2 ions. So this chemical reaction is used as an identifying test. Students, the second topic of today's lecture is about copper, having atomic number 29. It is brown-red metallic element and is one of the most widely used metal. Students, the common oxidation states of copper in its compound are cuprous or copper 1, which is also written as Cu+1, and the second oxidation state is cupric or copper 2, which is also written as Cu+2. So these are the two common oxidation states in which the copper compounds are found in nature. Students, most of the cuprous compounds means compounds in which the oxidation state of copper is +1. They are usually colorless and they are diamagnetic. Why is it so? Because the 3d orbitals, they are completely filled. It is going to have an electronic configuration of 3d10. This is copper having atomic number 29, and the valence shell electronic configuration of elemental or atomic copper is 3d10 4s1. But when it is present in copper plus 1 oxidation state, the electron from 4s1 is going to get excited, and we will be left over with 3d10 electrons. And they are completely filled, that is why it is diamagnetic. And it is colorless because no electronic transitions are going to take place between the degenerate d orbitals. And students, most of the anhydrous cupric compounds, means copper in plus 2 oxidation states, they are colorless, while they are hydrated when they are present in moisture or in solution. Hydrated cupric compounds, they are blue due to the formation of hydrated ions. For example, tetra aqua copper 2 ions and hexa aqua copper 2 ions. They are going to be blue in color. Students, the solutions of copper 2 salts, they are acidic. Means if we are going to dissolve copper 2 salts, a salt in which the oxidation state of copper is plus 2, the solution is going to be acidic in nature. And why is it so? Because the reaction is going to be hydrolysis. This is a copper 2 ions, or we can say the ion from copper 2 salt. When it is going to mix with water, it is going to get hydrolyzed. Cu plus 2 are going to attach hydroxyl ions, splitting up this water molecule, and a proton is going to get removed. Now students, this complex is soluble as it is carrying a plus 1 charge because the oxidation state of copper was plus 2. When one hydroxyl ion is going to get attached to it, it is going to be plus 1 now. Since one hydrogen ions is going to get released into the solution is going to be acidic. Now students, since the outermost shell of Cu plus 2 ions has one unpaired electron with an electronic configuration of 3d9, Cu plus 2 compounds, they are paramagnetic in nature, as you can see in this electronic configuration. Cu plus 2 ions are going to have valence shell configuration of 3d9 4s0, and this one electron is unpaired. Therefore, Cu plus 2 compounds, they are going to be paramagnetic in nature. Now students, just like the chemical reactions that we studied for iron ions with hydroxide ions, we are also going to study the reaction of hexa aqua copper 2 ions with hydroxide ions. Say we are going to take sodium hydroxide solution. The hydroxide ions are going to remove the hydrogen ions from water ligands that are attached in the copper ion complex to form blue colored precipitates of hydroxide of copper complex. Now students, this is hexa aqua copper 2 complex. When we are going to dissolve copper in water, we are going to obtain this solution. When we are going to add sodium hydroxide solution or any hydroxide solution, it is going to act as a base and remove protons from two water molecules which are present as a ligand. And the complex that is going to be formed is going to be tetra aqua dihydroxo copper 2 complex. Now students, since it is neutral complex, so it is going to give us blue colored precipitates which are going to settle at the bottom. So this is the same chemical reaction as we have studied for hydroxyl ions with iron complexes. Students, the next reaction that we are going to study is the reaction of hexa aqua copper 2 ions with ammonia solution. Ammonia acts as a base as well as a ligand. So first of all, let us discuss how ammonia acts as a base. When few drops of aqueous ammonia is added to the solution of hexa aqua copper 2 ions, it is going to act as a base and remove hydrogen ions from the water ligands which are attached in this complex. And we are going to obtain blue colored precipitates of hydroxide of copper. In this reaction, ammonia acts as a base and acting as a proton acceptor, that is why it is converted into ammonium ions. Now students, look at the chemical equation. These are the two ammonium ions which are going to abstract 2 protons from true water ligands, and it is going to convert into 2 ammonium ions. The leftover 4 water molecules are present as such, and 2 water molecules have been converted into hydroxyl ions. Now this is a neutral complex, so blue colored precipitates are obtained as a result of this chemical reaction. Students, let us look at the color change. This is the hexa aqua copper 2 ions, which is giving a blue colored solution. When small amount of ammonia solution is added, it is going to act as a base and is going to abstract protons or hydrogens from these water ligands, and is going to give us a neutral complex in which blue colored precipitates are going to be formed, which is tetra-aquo dihydroxo copper 2 complex. Now students, after obtaining these precipitates, if we are going to add a little more ammonia, means ammonia in excess, then it is going to act as a ligand now and is going to incorporate into the coordination sphere. As you can see, a deep blue colored solution is obtained because of the formation of this complex, which is tetraamine diaquo copper 2 ions. Students, as we have discussed that ammonia also act as a ligand. When excess of ammonia is added to hexa aqua copper 2 ions, precipitates dissolve and deep blue solution of tetraamine copper 2 complex is formed. In this reaction, ammonia is going to act as a ligand. When we are going to further add ammonia, it is going to replace all the water molecules from the coordination sphere. It is going to incorporate itself and give us such a compound, which is tetraamine copper 2 ions along with 6 water molecules. Now these are the 6 water molecules which were present as a ligand in the coordination sphere, and ammonia has replaced them. So now it is a part of the coordination sphere, removing all the water molecules. Students, the last chemical reaction of hexa aqua copper 2 ions are the reaction with the carbonate ions. When carbonate is added to copper 2 ions, blue precipitates of copper 2 carbonate is formed. Now students, this is the same chemical reaction that we studied for iron 2 ions, in which iron carbonate was formed. In this case, copper carbonate is formed. Look at the electrostatic forces of attraction. Cu with the charge of +2 and carbonate with the charge of -2. So they are feasible enough to get into electrostatic forces of attraction, giving us an ionic compound, and it is going to give blue colored precipitates which are going to settle at the bottom. So when carbonate ions are added to copper 2 solution, it is going to give copper 2 carbonate with blue colored precipitates. Students, this was all about today's lecture. Try to study all these chemical reactions in comparison